I mean, people get confused sometimes because I'm actually an identical twin. My twin brother is Jan Kycia, and he's at Waterloo, so that's just next door. My brother was over at Berkeley, and he had just started the job, and he asked his boss, should I go to that conference in Georgia? And his boss said, no, you don't have any results yet. Just focus on your work. Well, next week, I'm at this meeting in Georgia, and there's this elderly professor coming down the escalator, and he's staring at me like furious. And I'm thinking, what the heck is going on? He thought that I was Jan, and that I had gone to the conference anyways. And so then, then he quickly went up the escalator and he looked at my badge and he realized that I was somebody else, and he figured out very quickly. But yeah, if you ever see me and I seem to not know anything about what you're talking about, it's probably my brother. Hello, my name is Stefan Kycia. I'm a professor here at the Department of Physics at the University of Guelph, and I'm an experimental physicist. My specialty is working with X-rays and X-ray diffraction. The thing is that we're able to resolve details in our nanocrystals that nobody else is able to see. People can look at a nanoparticle in a microscope and they can say, okay, it's a little sphere. But do they know where the atoms are? We can tell where the atoms are. The one way to think about it is like there's always new materials coming. We don't even know what's next. Long ago, there were metals. So people wanted to understand, why is one alloy different than another? Okay. Then came along, let's say, semiconductors, and you started creating computers, transistors, right? Well, how does the material science of that? Okay, you need X-rays to solve that. We need to define how we're going to use X-rays to study semiconductors. Okay. Then came, for example, liquid crystals. What's a liquid crystal? A liquid crystal is something that's, let's say, liquid, like water, in two dimensions, but crystalline in another. And so we have liquid crystal displays all over the place. And how do you characterize that? You need to define how you use X-rays to study a liquid crystal. We've had to redefine how we use X-rays to study them. And so what my group does is define those new ways to tune and use X-rays to study these new systems. Actually, I grew up in New York, Long Island, right next to Brookhaven National Lab, because my parents both worked there. I grew up not knowing that I was going to be a physicist, but just sort of being aware of science and math and technology, and just being interested in thinking that this was something that was going to be accessible to me. I could do that. And I didn't know what type of math or science I was going to do, but I figured at one point I would. And so let's just study hard and be ready for the day I know which direction to take, And so I started off actually being a math and physics major with a music minor. And then as time went on, I zeroed in a little more. You can't do everything. So then, I went straight into physics after second year of undergrad. And I transferred from Stony Brook University in New York. In my first year, I moved to McGill, where I did 3 years of undergrad, which is actually typical over there, and in the honors physics program. I went to grad school at the University of Pennsylvania, and I thought that would be, I sent out my resume to all sorts of places, and me and a group of friends, my brother as well, we went over there, and I got my master's degree there, working in condensed matter physics and using X-rays. I can say that at some point I didn't always know that I was going to go in the direction I did, and actually I felt like quitting it back then as a master's student. Not quitting, but switching into something else. And so all of a sudden, from feeling like I didn't want to do this stuff to all of a sudden realizing that it is actually can be a lot of fun. It was a turning point. But the funny thing is I in the middle of all of that, I had already chosen to go to Iowa State University and work on quasicrystals. I moved on from there. I went to Cornell, did my postdoc. So from there, I went to Brazil. So there I led an X-ray diffraction group By that time I was about 30 years old, and it was really a lot of fun to work at the first synchrotron south of the equator.
Wow.
Really amazing people I got to work with. And then finally I came here, and that
Wow.
was 20 years ago, and I didn't think I was going to stay here this long, and I think a lot of people think that when they move to someplace, but I really loved it here at Guelph, and I've typically had a group of graduate students and undergraduates. I really like a group of about 4 or 5. I hire undergraduates from the second year, third year, fourth year undergraduates to work in my group, and there are all types of projects. We do experiments at the Canadian Light Source, and that's in Saskatchewan. When I arrived back in 2004, there was no capability to do the diffraction that I do in Canada. As an assistant professor, I led this thing, which I think is amazing, and that's part of what makes Guelph so special. It was really like this place was just pulling me forward and wanting me to grow as a professor. Anything, there was nothing impeding, okay, any professor here, okay? That's really great. That's still the case. Guelph is a fantastic environment for the faculty, and that's important, okay? If you're a student working for faculty that are grumbling and unhappy, it's not good. It's been a pleasure being a chairman of the physics department, because it's just everything works very, very well. I mean, I have been invited to go to other places since I've been here. I stayed, okay? And I stayed here because the students are great here. Fantastic students. If you're a self-motivated person, then Guelph is a fantastic place. You're not going to be driven faster than you want to, and you're not going to be put a lot of pressure on you, really. But if you're motivated, you can do anything you want. You can go as far as you want.